I do not hate this one. That's a good way to start. So you got two handouts today. You got exercise 214, which is what we're going to do in class, but you also got assignment 203. I recognize you're still working on assignment 202. These kind of overlap a bit, but it's just the way the semester works out. This is due on Monday, the 5th of November. So it's still a bit out. And so in this class, you tend to get pretty long lead times on when this stuff is due. A couple things. One, we're designing a skyscraper for this, which is fun. Two, it is not as in-depth of a skyscraper as the Skyscraper Studio. This is like the precursor for those of you that are going to take 221. We are purely considering form. I'm also not overly worried about the structure of the building. So I'm not going to grade you if it's going to fall down. That's OK. There is no gravity in Rhino, so life is great. It is larger than the building that we're doing today. So you can't use the same. You have to do a new building. It could be a variant of the building, but it is going to be larger. It's going to be 808 feet tall, and the footprint is 100 by 200 feet. A couple things that are important for you guys to know about this is that it's kind of a three-part assignment. The first part is obviously we're going to build it in Rhino, and then we're going to render it in V-Ray. And I want really good, high-quality renderings. The fun part of that is we're finally going to get into environments where there's sun and context, and you're no longer in that blank white space. So that's a good thing. So there'll be renderings. There are, let me just double check here to make sure I get this correct. There are 3 renderings required. So you have to do 3 different views of your building. And I noticed this semester after semester, for whatever reason, you guys as students don't like to read what I hand you. Read it? I know this sounds silly, okay, but it happens like on the final. People are like, why did I fail the final? Well, you could have read what it says. So like, I'm specific, like 3 renderings. If you turn in 1 rendering, you get zeros for the other 2 renderings. Your grade does not look good at that point. So when I say 3 renderings, I mean 3 renderings. If I say 3 renderings and you give me 4, hey, that's cool. I'll pick the best 3. But if you give me, yeah, I won't pick the worst 3. I'll pick the best 3. If you give me 1 rendering, I only have 1 rendering to grade, and I will not grade that 1 rendering 3 times. So it doesn't work that way either. So I'm just like, I'm beating you over the head with it now. But I'll remind you when it comes down to the final, too. So just like make sure you really read this. If you need like a highlighter or something, highlight it. Like, please read it, OK? So we're going to do 3 renderings of this. That's due. Then we are also going to do 2 more things. The first thing is we're going to prep a file to 3D print. And you're going to actually turn in an object file and, I hope, this semester, a G-code file so that you could actually print it. The actually print it part is a little challenging because I have to make sure that the 3D printer is working and is playing nice and all that stuff. The goal for the class is for all of you to have a little 3D print of your skyscraper by the end of the semester. The actual physical 3D print is not the graded part, though. So I want the files, that's what I'm grading. And if the 3D print works, that's like a bonus. And you get to take that home. So fingers crossed that it works. That should be. So that's the second part of this assignment. The third part of this assignment is that we're going to unroll all the surfaces and fold them flat such that if you cut them out on a laser cutter, you could actually glue and make this back together. So it's kind of like a, when you, in 130, when you did those constructions of the paper and they folded out and you folded them together and taped them. It's the same concept. I want you to be able to do that of a skyscraper. So I'm going to teach you how to do it, and that will be a requirement. So there's actually 3 major parts to this assignment, all of which we will do in class as we go forward. So we will do it on the sample file, this one. You will be doing it on the assignment at the same time. Okay? So just make sure you actually read it because there's lots of different pieces to it, and make sure you turn in all of the pieces so that I can give you credit for all of the pieces. OK, so today, I hope you guys have some fun today. Building skyscrapers, thinking about form of skyscraper is a fun sort of deal. So please have fun with it. Don't feel like, oh, I have to make this rectangle and it has to stand up, or like be goofy, have a good time with it, and that'll make life a little bit more exciting. So we're going to start in the world of Rhino. I have a blank Rhino document up here. And I'm going to start by creating just a basic shape. And the other thing about today is iteration is a good thing. So build lots of these, because you're going to find as you build lots of them, I mean, I would build 10, 12, 15 of them, and you're going to learn which ones start to work and which ones don't really work. So it's kind of an exploration in form. So I'll start with the box corner-to-corner tool. I'll start at 0.00, and I'm going to do the base, which I said was 100 feet by 200 feet. So I said at 100 feet, comma 200 feet. Enter. I'll zoom out a bit. And this is going to be 600 feet tall, I think. Right, 600 feet. And there it is. So there's our basic, really boring building. At this point, I want to talk to you guys about transformations of shapes. And how do we modify a particular shape and change it into something else. And there are obviously a large different variety of ways that we can do this. But I'm going to kind of show you different pieces of it. So the first option is with any one of these shapes, there are actually control points that define the shape in the first place. So I can come over here and choose to turn my edit points on, or in the command line, I could just type points on, which is written out on your sheet here. And when I do that, I get a few control points. So in this case, they haven't given me much. They've given me this one control point here. I could then move that control point. And as I start to move it, well, it's laying it down right now. Let's see if I can move it. Yeah, all it wants to do is lay it flat for me. So it's not really doing too much. If I took this shape and I exploded it first, and then turn my edit points on. Oh, sorry. Points on. Should have typed it. There we go. I'm going to get more points. I get points in all 4 of the corners. At that point, I could select those 4 points. I could move those 4 points. And I could start to lean the tower. I could also type rotate. And I could rotate that tower. So I'm doing that by manipulating the control points of this particular polysurface. And once again, I'm doing that. And actually, I could rejoin this together again. Sorry. By taking my object and exploding it from its basic primitive so that it's an actual polysurface, join it back together, and then turn my control points on, or type points on. No, it's never mind. It's not going to let me do it as a polysurface. So I'd have to explode it. And then I can do my points on. There we go. So I get those control points at the top. So that's one option. I don't have a lot of flexibility, though. Even in this scenario, I have 4 points on the top, I have 4 points on the bottom, and that's it. So I'm going to introduce you to something new that's called the cage edit command. And so once again, I'll do another at 100 feet, comma 200 feet. Oops. Helps if I type correctly. There we go, by 600 feet. And actually, I'm just going to take this one and make a copy of it over here so that I can just keep copying it rather than having to recreate it. So I have this shape here, and I want to start to transform this shape. And I'm going to use something called a cage edit. And what a cage edit does is it essentially puts like a wireframe cage around your object and lets you twist and manipulate whatever's inside. And in this case, the cage is going to look an awful lot like the building. But I could have some kind of a little rubber ducky inside a cage, and I could tweak and pull it, and it would do the same kinds of edits. So it doesn't matter what's inside the cage. It's just the fact that we're transforming what's inside the cage using this cage edit command. So to initiate the cage edit command, it's under transform cage edit, or cage editing down here, and we're going to go straight to cage edit. You can create the cage first and then do a cage edit of the cage. I think you could just skip the step and go straight to the cage edit, and that works out just fine. You can also type into the command line cage edit, and you'll get to the same place. So if I select cage edit right now, it's going to ask me to select the control object. I don't have a control object. That means the cage that's going to do the editing. I don't have one. So I'll use a bounding box just to completely contain my object. That's usually a good strategy. So I'll do a bounding box. The rest of these options tend to be just the defaults. We'll do it as a world. Whoops, sorry. There we go, world. Now we get to the cage points. And we've got a couple different things going on here. We've got an x point count, a y point count, and a z point count. We also have an x degree, a y degree, and a z degree. And this is the kind of thing where I'm going to have to show you each of these to start to let you understand what's really happening here. So first thing, under x point count, these are the number of points in the x direction. We don't need 4 points. We could actually get away with just 2. That's going to give me 2 points in the x direction. So the x is going this way. It's going to give me 1 point here and 1 point there. That's it. The y point count, once again, I'll switch to 2 because I really only need 2 points in that direction. So it would be 1 here and 1 there. The z point count is how many divisions in the vertical direction that I want. So for our purposes right now, I'm going to, sorry, that was supposed to be the z point count. I'm going to set it for 3. And what that'll give me is a set of points at the bottom, a set of points at the middle, and a set of points at the top to manipulate. So x point count is 2, y point count is 2, z point count is 3. Some of you might have noticed that the x degree, the y degree, and the z degree changed when I changed those point counts. They changed on purpose. When I switched to an x point count of 2, the degree had to be 1 less than whatever the x point count was. So the degree went to 1. When the z point count went to 3, the degree went to 2. I'm actually going to keep the x, the y, and the z all at 1 for illustration purposes right now. And then we'll move on and do it as a 2 in just a second. So I have x point count as 2, y point count as 2, z point count as 3. My x degree, y degree, and z degree are all 1. At this point, I'm ready to hit enter. Region to edit, that's default global, and that's it. And you see, as soon as that is done, we can see the points showing up on my objects. So I'm going to select all those points just so that you can see them a little bit better on the screen. And it did give me 2 points in the x. So there's 1, 2. 2 points in the y, 1, 2. And 3 sets of points in the z. 1 at the bottom, 1 in the middle, and 1 at the top. So these points are the cage that allows me to transform my building. So I can select any one or a multiple group of these and transform them. So for example, I could select just this middle set, and I could do a rotate. I could rotate from there, and we'll rotate over a little bit. And it rotates the shape that was inside my cage. I could take the top, and I could rotate the top back the other direction. And it would rotate the top of the building. The degree, the x degree, the y degree, and the z degree, is telling the computer that between these points, we always want a straight line. So no matter how I move them, they're always going to be a straight line. If I took this single point here and I moved that point like that, it's still always going to be a straight line between the other points. There isn't going to be any curvature between them. So you saw that I was able to adjust these points individually. So I could take those 2, for example, and I could move them out this way. So you can see I can manipulate this in a lot of different ways. It is keeping the same basic shape underneath. I'm just choosing how to manipulate these various points. I could even pinch that in the opposite way like that. So I've got a lot of flexibility in what I do. I'm going to leave that one there. I'm going to copy this one over, and we're going to continue to play with the cage editing. So there's a fresh shape. We'll go back into cage edit. My first option is bounding box again. My coordinate system will be world. That's fine. And we're back to our cage points, x point, y point, and z point. Now, if I switch the x to 3, the y to 3, and we'll leave the z at 3, I can switch the x degree, the y degree, and the z degree all to be 2. So there's 2, and there's 2. Now that all of those are set, I'll go ahead and hit enter. Region to edit global, yep, and there we are. So the difference here is because x was now 3, I have 1, 2, 3 points in the x, and I have 3 points going in the y direction. So there at my bottom, you can see I actually have 9 total points. 3 by 3 gives me 9. I have 3 in the middle, and I have the top. So now as I start to manipulate it, it's going to work a little bit different. Let's do the same rotation that I did before. I started with the rotate, and I rotated from here to here, and I rotated this way. Notice that when I rotate, it's no longer giving me an angle like it did here. Because my curvature is set to 2, it's giving me a curve between those points. Likewise, I could come up here to the top. I could rotate. And I could rotate this one back a little bit, and we can exaggerate the curve. So it's actually curving the shape underneath. This shape should, because it's a two-dimensional curve, still be what is called a ruled surface, which essentially means that it's a straight line between this curve here and that curve there. This kind of surface is something that we can build easily in the field. We could actually build a building like this. Furthermore, it's the kind of thing that you can take a piece of paper and you can twist it to create that kind of a shape, because it's always a straight line between 2 points. So it's a very buildable surface. It is also something that Rhino is capable of unrolling flat and laser cutting, which is a good thing. I could continue. I can move some of these points. So I could take this point, I can move this out, and we can start to manipulate it a little bit further. You can see that I can really start to mess things up. So if I were doing this, I probably would stick with, over here, let me do a cage edit again. Sorry, I can't type. Bounding box, world, and here I would probably stick with an x point count of 2, a y point count of 2, and the z you can float to whatever you want. So let me go ahead and up this again. We'll do it at 4, which gives me the ability to adjust to a 3-degree or a 3-dimensional curve if I wanted to. As soon as we start to get into 3-dimensional curvature, Rhino's not going to be able to unroll the surface flat anymore. And remember, as part of your assignment, one of the things that you're going to have to do is unroll the surface flat. In some cases, you'll run across Rhino not being able to unroll the surface. If that's the case with your building, I'm OK with it. You're just going to do another simpler version of your building that you can unroll. And I'll show you what happens when we get 3-dimensional curvature. So let me go ahead and put that as a degree of 3. We'll hit Enter, region to edit global, and there we go. So at this point, I can start to manipulate these points a bit. We could do a rotate again. That's still primarily a 2-dimensional curve. However, if I took one of these points and I moved it out like that, well, it may stick there. I may actually have to do, let me do one more, and I'll do all of them at the 3-dimensional curvature to illustrate this a little bit better. OK, so when this fails is when I take a shape and I rotate it like this, and then I take this point and I pull this point out like that. So this looks similar, but the problem here is that this is like a sphere. It's like the globe. You guys remember, like in elementary school and high school, well, maybe you looked at, I don't know, middle school, high school, whatever. You remember those maps that they pulled down? And they had like the different types of world projections, and they had the one with the little like orange peel splits in it, and then they had the one that made Canada look gigantic, right? Those are classic. Essentially, we run into the same problem with this building. So I have curvature in 2 directions. I have curvature going this way, and I also have curvature going this way. I can't flatten this out without splitting it in some way. So there is a command in Rhino that will attempt to do it, and we'll kind of split it out. It's called, I think it's called splat. Anyway, I don't ever use it. But it's kind of like taking an orange and trying to peel the orange. You can't take the peel off an orange in one piece. It doesn't work. So that's the problem. So if you can, try to stay away from that kind of curvature, as sexy as it can look. In practice, this is really difficult to build. Like if you went to a contractor and said, I want to build this building, they would have a really hard time engineering it and figuring out how to build it. So most of the twisting surface buildings that you see out there are not this kind of surface. They're straight line surfaces still, where they appear to twist, but the straight line, it's basically, it's called a ruled surface, the straight line twists. That's a very doable construction technique. So these are the different kinds of cage edits that you can play around with. If you stick with the two-dimensional curve, you're more likely to get good results and be able to unroll it. You're going to keep playing around with strategies, but it does not mean that you have to just start with a rectangle and manipulate that rectangle. So instead of working with the rectangle, I could, for example, start with a rectangle at the bottom. So let's say at 100 feet, 200 feet. And I could take this and I could say, you know what, I'm going to turn on my object snaps. Let me snap to midpoint. There we go. I'm going to take a chunk out of this corner. So instead of being an outside corner, it's going to be an inside corner. So I could trim. Gives me a plaza at ground level, whatever. I could take this and this. I could join those together. I could take, let's see, and I'm going to do another rectangle like this. I'll take this rectangle. I'll move it vertically 200 feet. Maybe I'll take this one and I'll copy it vertically by 600 feet. Like that. Then I could take this surface and I could loft it with this surface. So I can select them both, type loft. And I just have to make sure that I know where I want my corner points to be. So it's trying to line up that side. I actually want this point to match up with that point. I think that'll end up looking better. We'll go ahead and hit enter and we can take a look at it. And it's twisting a little bit more than I'd like. Yeah, that'll work. And I could take this here and I could loft it to there. Remember, I want those to match up nicely. So let's take this and put it down there in the corner again. Let's take this one and put it right there at the corner. And then we'll hit enter and enter again. And that gives me another shape. So this is obviously a much different way of building up the skyscraper, but there's nothing wrong with building it this way. Same strategy. A loft by its nature is always going to be unrollable. So you're always safe. If you loft two things together, you'll be okay. In fact, when I ask people to simplify shapes later on, if you end up with this kind of a bulge by accident or maybe on purpose and you need to unroll it, what I'll have you do is I'll have you duplicate the edges and then loft the edges together as a way of making it developable. So you can get creative and you can start to create something like this. Once I have this, I could also take this particular piece and I could perform a cage edit of this. So I could take this and I could go to cage edit, bounding box, world, go back down to 2, 2, and I'll leave that at 3 for right now. My degrees, yeah, that's all fine. Hit enter, global. There are my points. And I could say, you know what, I want this one to rotate a little bit. Maybe by 5 degrees. So it's just off. And I'll take this first piece, take that one right there. We'll rotate that one. 5 degrees. It goes that way. Maybe I need to exaggerate it so you guys can see it a little bit better. There we go. And so the point is that I'm transforming this shape into something that's even more twisty. And I can get away with that because Rhino will allow me to do it. So once I get to the point where I'm starting to feel happy with whatever my final building is going to be, and for argument's sake, let's say it's this particular building. I'm going to make a copy of it, put it over here. Now I'm going to start to work with this particular building and make it into an actual building. We're going to be using these buildings for several classes going forward. So take your time, make something enjoyable to look at, and then I'm going to show you how to transform this into the actual skyscraper itself. Many times you'll end up copying it and putting it at 0, 0 and getting rid of the rest of them. You could at least take the rest of them and put them on their own layer. Let me go into layers, and let me change the objects onto this layer, which would allow me to turn those off, and I could move this back to 0, 0. So now it's back at 0, 0. Now I need to start to think about this as a building and divide it up into all its floors. So I'm going to start first by working with my layers. So over here under layers, I'm going to make a layer called floors. I will also make a layer called ceiling. And we'll get to more. And actually, let me change the default layer here to be called skin. There we go. So let me make the floors layer active. And I'm going to start by creating a rectangular surface, not a rectangle, an actual rectangular surface right here. And I want this rectangular surface to be larger than my building. I can do this in the top view pretty easily because I can look straight down on my object and make sure that my rectangle is larger than my building. If you're doing it in the perspective view, sometimes you end up creating a larger rectangle. It really doesn't matter. So at this point, I need to start to divide this up into floors and ceilings. So the lobby floor is a little bit larger. And I realized in the exercise here, I say make every floor at 10 feet. I don't like that. I like the assignment floors better. There's a lobby floor, and then there's other floors. So I'm going to follow the assignment part instead. And so what I'll do is the first floor is 24 feet. So I'm going to make a copy of this surface. I'm going to say copy. And using the copy command, this, by the way, is the transform copy command. If you just type copy, point to copy from, do I want it to be vertical? Yes, I want it to be vertical. So I make sure I type in V or click on vertical. Point to copy from would be right there. And we're going to go up by 24 feet. And there's my next floor. At this point, I'm going to have a lot more floors going up from here. And they're going to be every 16 feet. So I'm going to copy again. V for vertical. I could start here, and I could go up 16 feet. Now, the problem is, yes, I could do the next one at 32, but at some point, I'm going to run out of the ability to do the math in my head of adding the 16s together. And so instead of doing that, it's actually a lot easier to work with the array command. So I could start with just this first one. Notice I did skip the first 24 feet because it's different. So I did that as a copy. Then from here out, I could actually do an array. So I'll type in array. And this, kind of like those panes of glass that we did, I'm doing the same thing. This time I'm stacking them up vertically. So the number in the x direction is going to be 1. Number in the y direction is also going to be 1. Number in the z direction, this is how many floors there's going to be, is probably going to be like 36 or so. I can adjust it afterwards. I don't remember off the top of my head how many there were going to be. I'll hit enter. Z spacing or first reference point. I'm going to pick my first reference point as this right here, this corner. And then you can see the floors start to materialize. The spacing, or the second reference point, would be at 16 feet. So I'll type in 16 feet, and I'll hit enter. It hasn't actually, and I have to choose a direction. Obviously, I want it going up, not down. It hasn't actually created it yet. It's giving me the opportunity to adjust and to add. So I had 36. Maybe I actually need 37. So I get 1 at the top. There we go. That feels a little bit better. So I can make those adjustments in the number or in the spacing if I need to after the fact. Once I'm done, I'll press enter. And now I have all my floors going up the building. So those are my floors. My ceilings are going to have a different material on them, so I want to create a different ceiling plane. So let's take the first one right here, and I'm going to make a copy again, and I'm going to drop it. I'm going to go vertical, but I'm going to go down. And we'll say -4 feet. And the reason that I'm picking 4 feet is that this gives me space for building utilities and stuff that goes in the building itself. There's structure, there's trusses, there's a bunch of stuff that goes in there. It doesn't really matter what goes in there. The scope of this class doesn't cover that sort of thing. Just trust me, there's stuff that goes in between the floors.
What about the thickness of the slab for each floor?
I'm not so worried about the thickness of the slab because I'm not going to take a section of it. I'm not really showing that level of detail. In this case, it's really kind of a form exercise more than anything else. So the top of these surfaces are going to be concrete. The bottom of these surfaces that I'm about to create are going to be whatever the ceiling is. Yeah, basically gypsum board or white, for lack of something better. So now that I've created that at 4 feet down, I can once again do my array. And the number in the x direction would be 1. Number in the y direction will be 1. Number in the z direction is going to be 37 again. And my z spacing, our first reference point, starts here. Now, one of the things that people end up doing at this point is, because this essentially makes every floor at 12 feet, is they type in 12 here. Well, it's not 12, it's not floor to ceiling, it's ceiling to ceiling. So it's every 16 feet still. So you want to type in 16 feet again, and that gives us all those floors. Before I do it, though, so I don't have to select them all, I really should change this to the ceiling layer. So let me right-click and say Change Object Layer. Now it's on the ceiling layer. Now I'll do the array. Saves myself a bunch of clicking later on. So we'll do that array one more time. Number in the x direction is 1. Number in the y direction is 1. Number in the z direction is, again, 37. My z spacing will start here, and it's going to go up by 16 feet. And it's going to be in that direction. Asks me to confirm my numbers. Yep, looks like I made it all the way to the top. I'm happy. I'll go ahead and hit Enter to accept. And there we go. So now I have all of my floors and all of my ceilings defined. They're sticking out of my building, which is not what I want them to be. I want to, at this point, trim them off so that they're not sticking out anymore. So I'll use my skin, which is right here, as a trim. I'll go ahead and type in trim, and I'll trim off the extra pieces of skin. Now, I wouldn't recommend doing this and trying to do them all at once. It's a little bit hard for Rhino to do this, so do them in small groups. You're less likely to freeze things up if you do it in small groups. So I didn't select the bottom part of the skin, so I'm having issues. One more trim, there we go. And we get down to the last little bit. So all of those have now been trimmed out, and we can see my building with all the floors. Okay, that seems pretty good. Now, in order to access a skyscraper, we need some kind of a core that has elevators and stuff in it. So we need to be able to punch that up through the building. So I'm going to work on layer 4 here, and we'll call this core. And I'm going to build basically an elevator shaft through my building. So we'll start looking at all 4 views so I can work in the top view here. The reason that I'm kind of working in the top view is I want to make sure that it falls inside of my building and doesn't end up hanging out one side or the other. So I'll start with just, we can do a box corner to corner, or we could do a rectangle corner to corner. Either way, I'll do the rectangle, and I'll say maybe at 30 feet, comma 30 feet as a core. Something like that. And we'll assume that elevators and stairs and stuff goes in there. Now that I have that, I'm going to position it such that it seems like it goes straight up through my building. Obviously, elevators don't go on angles. They go straight. So it makes, well, I guess theoretically you could get an elevator that went on an angle. It would just cost like 20 times as much as a straight elevator. And you'd have to be like Apple or something and have enough money to say, no, I want a crooked elevator or whatever. The point being, we don't have that kind of money, so we're going to do it straight. So I have that. I can come back over here into perspective view, and I'm going to extrude curve. And this is one of the times where I really don't need it to be solid. So I've always been telling you, oh, make it solid, make it solid. In this case, I don't need it to be solid because I just need the 4 outside lines. So I'll make sure that my extrusion distance is either 400 feet or I snap to the top of my building. So there it is, snapped all the way up through the top. And I can use that as a trim. So I'm going to look down on my object, and if I position it just right, I can zoom in here, and I can look down that elevator shaft. Once I'm kind of looking down that elevator shaft, I can type in trim, and then it's a matter of clicking in the center here, and as I start to do it, as I repeat, the elevator is just going to go down through the building. There we go. And so we made it all the way through the building. So at this point, I have my building defined. I have an elevator shaft that goes down through the building. In all reality, I probably need a little top to the elevator shaft, so I could come back to this box tool and I could make a little top, I'll say maybe 16 feet. Oops. There it is, just so that I have a little top on it because the elevators need space for the mechanical systems and whatever. I'm not overly worried with the top of the roof. We're going to do renderings from street level, so it doesn't really matter for our purposes. So now I have my building kind of defined. I've managed to get the core all the way through. I've gotten all the floors. It's now time to start assigning some materials and getting this to look reasonably good. So a couple things. One, I'll go ahead and save this before I get too far. I'll go to File and then Save, and I'll put it into today's folder. What are we on? 214? Yep, there we go. This is the Skyscraper for fall of 2018. And there we go. So I have this saved. Now I'm going to go through and make sure that all my materials are applied correctly. So glass, I told you, is still a little tricky because we have no environments yet. So using real glass is a little bit hard. So what I've done for you is I've created a specialty skyscraper glass that you can use. So I'm going to go into today's exercise. And at the bottom of today's exercise, I thought I had it linked there, but I don't. I have it linked on the next day's exercise. So, yeah. If you downloaded the material package, it may be part of it. If not, I'll put a link to it there. I haven't loaded up my V-Ray tools yet. So let me go into my tools and then toolbar layout, and let me load up V-Ray. I'll go to File and then Open. Is it there, the skyscraper glass? OK. And I'll go to my resources. There's my V-Ray. And I'll go into my V-Ray materials. I'll right-click on materials. I'll say Load Material. And I'm looking for a couple different things. I'm looking for the floors of my building. I'm looking for the ceilings of my building. And I'm looking for a skyscraper glass for the outside of my building. So we'll start with the floors. So let me go into my flash drive, into my resources, into V-Ray, V-Ray materials. I'm going to do concrete. I'm just going to do a basic concrete. There it is. Once that's loaded, we'll confirm that it loaded correctly. I'll right-click and say Apply Material to Layer. And that's going to then go on the floors layer. So all of those have that applied. I'll right-click on See Materials, go to Load Materials. Now I need my ceiling material. So I think I have it under Interior Wall. There we go. Textured Sheetrock White. And there it is. I can apply that. Apply Material to Layer. And that would go on the ceilings. This, by the way, in your sheetrock material here, if you wanted to change the color, if you wanted to paint the ceilings a different color, all you have to do is change the color of the material. And it'll do it. It does have some texture on it, so it's meant to have a little bit of texture. You can change the color just by clicking on the color. There are some websites, I should give you guys a link to it, where you can actually figure out what the color of various paints are. So if you knew that you wanted a specific bare paint, you can figure out what the color is and then put it in here and have that color. So you could change that if you wanted. I'm going to leave it as white. I've already applied it to the ceilings, right? Apply material to layer. It should go on the ceiling. There we go. Next one is the skyscraper glass. I'll go into Load Material. And I'm not sure if all of them are there. It would be under Glass. Let's see if I can find it. Glass. There is a regular skyscraper, and then there's a dark and a light. The skyscraper dark and light are the two best ones that I've done for the skyscrapers. If you're not seeing those, I'll put links to those so that you can download those, because I can't remember whether they got updated into the material package or not. Anyway, I'm going to use the light skyscraper glass. There it is. We'll go ahead and open that. And when I click on the glass and preview it, it doesn't look like much, but that's okay. The reason that this is a good material is it's fake glass, and it tries to mimic the reflectiveness of a skyscraper. And so that helps a little bit. So we'll go ahead and apply material to my layer. And we're going to do it on the skin layer. Perfect. Like that. So I have my materials applied. Oh, I've got the core. I should probably make the core layer concrete. So let's change object layer. Sorry. Let's go to materials. And we'll use the basic concrete again. Let's load a different material. Let's go to load material. And in concrete, we could do a horizontal plywood with form ties. Sure. So it looks a little bit more like a wall. There it is. We'll right-click and say Apply Material to Layer, and that'll go on the core layer. Perfect. And so now I have all the materials applied. I should probably spend a little bit of time texture mapping and make sure that the texture maps look good on these various materials. I'm not overly worried about the floors and the ceilings. We're going to be rendering from far enough away. It doesn't really matter. But if I was going to create a rendering from inside one of these floors, I would obviously want to spend a little bit more time getting the texture mapping right. Our renderings are going to be from the outside looking, so I'm not overly worried about it for now. You can confirm that this is working by switching into the rendered mode and taking a look. The skyscraper glass looks kind of funny, and that's the nature of it. The preview never quite looks right. That does take some texture mapping. I'll spend a lot of time next class talking through it again, but I will show you today, even though it wasn't really my intent to show it to you today, just so that this looks a little bit better. So I'll start with a relatively straight side. We'll work here. I'm going to work with my lower part of the glass instead of my upper, and then we'll copy it to the upper. So right there, I'm going to go over to my texture mapping, and we're going to create a box map, because this is roughly a box shape. Create a box map. We'll do a bounding box. We're going to do it as world, and it doesn't matter whether we cap it or not. I'll say no. And once I've created that, I'm going to come over here and I'm going to show the mapping, which gives me this rectangle. This rectangle, and the way that this material works, is it's representative of a single floor with a single panel of glass. The panel of glass is designed to be 4 feet. So I'm going to do a scale 1D. If I'm in my command line, scale 1D. And I'm going to snap from that to that. And I'm going to make this smaller until it's at 4 feet. I'm going to scale again from this point to that point, and I'm going to make this smaller until it's at 4 feet. Then I'm going to move this, V for vertical, until it's 16 feet up, not 126 feet. That was supposed to be 16 feet. Sorry, 24 feet. There we go. So it starts at that first floor. And then my overall height is going to be the height of a floor. So that's 16 feet. So one more scale, 1D, from the bottom to the top, and that would be 16 feet. And you can see that as I do that, it starts to kind of divide this up into little individual panes of glass, which will help the overall look. I know the bottoms of these are transparent. They're not supposed to be, but it's the way it previews. Sorry. So we can also kind of see in now, and we can see that my floor texture mapping is not the best. So I'm going to need to spend a little bit of time texture mapping that. I can hide the mapping widget now. So we'll go ahead and hide that mapping widget. And I can also copy my texture map onto this surface up here. So I'll take the surface, I'll say match mapping to that surface there, and now it matches all the way up. My texture mapping on the floors, we could go and just apply a surface map. And my repeat here is probably more like 15, maybe 10. Maybe have to get a little closer to see. Yeah, maybe more like 15. Something like that to get the texture right. I could select all of my floors except this one. And I could go over to my mapping. I could say match mapping to that, and now all of those have the same mapping on them. Same thing with the ceiling. if I wanted to spend a little bit more time. I'm not going to worry about the ceilings. You're not going to see it. It's going to show up as white, and that'll work out just fine. Unless I was doing a rendering from the inside. So I have my texture mapping applied. I should double check. Yeah, my core probably needs some texture mapping on it. Remember, because of the layers, we could turn off the skin, we could turn off the floors, we could turn off the ceiling, and we'd be left with just the core. I'll take the box up top first. Box map, bounding box, world. It does need to be capped. I'm going to do x equals y equals z to kind of even those out. And it would be helpful if I knew how tall this is. So this is 16 feet. This is a 4x8 sheet of plywood, so there should be 4 of these. 1, 2, 3, 4. So I need to adjust this repeat a little bit. So let's go down. Let's try 250. Oops, sorry. This was supposed to be locked. Wrong direction, 350. Yeah, that's actually fairly close. Remember, I can go back into my mapping, and I could adjust this. We can move it vertically. Oops. Until it's looking the way I want it to look. We can say like that, for example. That's good. And then I can go back and I can match my mapping. So I can take this object here, I can match the mapping to that object, and now they're all matched up together. Okay? So now that I have those set up the way that I want to, and maybe you'd run these vertically, I don't know. Now that I have that set up the way I want to, we can turn everything else back on. There we go, except for my original buildings. Let's clean up the layers just a little bit. Let's give myself a skyscraper layer. And let's give the skin, the floors, the ceiling, and the core all sublayers. And I'll go ahead and save this one more time. And I may just get rid of these two. Oops. So then I'm back to just the skyscraper and just the skin, etc. So now that that's ready, I'll save it. And it wouldn't be a bad idea for my rendering to go ahead and open that exercise 208 sample file. Remember that I gave you guys a while back to do the rendering? Go ahead and open that, bring it in as a block to confirm, because that already has some of the basic settings for me. So let me open up Rhino again. And I'm going to go back into exercise 208. There's my base file for test rendering. There it is. We can bring in my skyscraper. I'll go to File, and then Import, or excuse me, Edit, Blocks, Insert Block Instance. I'll go find that skyscraper on my flash drive. There it is. I'll say Open. There's my skyscraper. All is good. I'll say OK. Right here, I want to link it as a reference. I'll say OK. And we'll drop it in right at 0, 0, 0. And now we can zoom selected, and we can see my whole skyscraper. At this point, we can go ahead and do our test renderings. So it's just a matter of opening up our render. Oh, I don't have my V-Ray toolbar, so I'll just skip ahead to rendering it. And we'll take a look at what the skyscraper looks like. I don't expect it to be perfect because we haven't installed good environments yet. We don't have clouds in the sky. We have nothing to reflect. But you should be able to get a decent result out of this to see your building. So that kind of makes sense for the trajectory for today. So the first hour or so, just play around with form. Have a good time. I mean, I did 10 different buildings. Do 15. Just create a bunch and decide which one feels right. Once you kind of distill it down, that's when it's time to punch the core through the building. And then once you get that figured out, then spend the time with the materials and getting that identified, get your texture mapping correct, and then you can bring it over and do the actual rendering of it. Like I said, the Skyscraper light and dark links for those materials, if they're not in the materials package, I will update them so you can download them from the website. You just got to give me a few minutes to do that. They should have been there for you today. All right? If you guys have any questions, let me know, and I'll help you get through it. And so there's kind of your final rendering for today. You will need this for next class, so I expect you guys to have this. We will put it into the city of San Francisco, so you'll actually be able to put your building into a real context, which is good. We'll do some renderings, and we'll also work to install a sun and sky system so that you guys can actually do some real renderings. I'll also at that point teach you distributed rendering, so you can start to use the rest of the computers in the lab and the render farm to do your renderings, which will speed things up just a little bit. So that's what's coming next class.